okay, if you say so.
Yeah, I can get 100 grade as Chinese.
In Chinese?
For mark is 100.
You can get 100 in Chinese?
Yeah. 100.
Not 120? Yeah. Middle school, okay.
High school is 150. And I can get 110.
At middle school?
At high school.
Not bad. So your Chinese is good?
Chinese.
Good for you.
I hate English.
It's a pity you must use English.
No, I want to go home.
Okay, alright, fine. Fine, as you like. Alright, so our last topic for electricity.
Next topic is very short.
Next topic?
Yeah, it's very.
Oh, there's homework on that, was there?
What's homework?
No. Next homework? Wait, what are you asking me? This is the next lesson.
Yeah, I know.
Yeah.
I mean, next topic.
Waves.
Yes.
Yeah.
It's
On Friday.
Very long or very short?
Waves is short.
How short you think? How many page you actually write down?
I don't know. I don't know.
How many page on this?
On this? This
Side, yes,
this is very short. So maybe
No.
the next,
Yes.
I don't know, there's maybe like 10 lessons.
10 lessons?
So I have changed the notebook.
Probably.
Yeah.
Yeah. Can I go on? So potential divider. Did you write this down? Yeah, okay. So this lesson is also very short. Okay. Right. Okay, so I want you to draw this circuit, please. So you have resistor, cell, voltage here, and a voltage here.
What's the in
Just voltage 1 and voltage 2. I'll explain why I call it V in and V out. Okay, so why here am I calling this V in and V out? Well, here's the idea. Sometimes we want to change the voltage. Okay? So V in is the voltage at the start, and V out is the voltage at the end. So this is a way we can change the voltage. This is the idea. Can you please use the loop rule, Kirchhoff's loop rule? I'll call this voltage here E. So what is the loop rule? E minus, what's this? I or 1 minus I or 2 equal 0. So if I use the loop rule, I get this. V in, the voltage here is V in, minus I or 1 minus I or 2 equals 0. Yeah?
V in is where we start
Yeah.
to
The voltage at the start.
Out is the voltage at that.
Okay. Can I go on? So, remember the formula V equals I or? So you can see here, this is also V out. So, oh sorry. What I mean to say is we can rewrite this to get the I. So I can say I equals this formula. That makes sense, doesn't it? Yeah? Is that okay? Yes? Okay. Now, do you remember the formula V equals I or? So we can say V out equals I or 2. But you have a formula for I, so you can get this. V out equals this formula here. Yeah? Yes, can I go on? So anyways, this is our result. The potential divider, that's the name of the circuit, allows for the input voltage to be reduced. And the voltage can be calculated from this formula. So this is our result.
Should I write that?
Yes?
Now, how many formula do I have this?
Huh?
How many formula do I have now?
Today?
No, only for this lesson.
Yeah, just that.
Only this one?
Yeah.
And if about this I equal Vn over R1 plus R2.
That's just the proof to get to the answer.
Can it be increased as well?
Good question. No. That's a good question. I don't know what's so funny. It's a good question. This can reduce the voltage, but it cannot make it bigger. It can only make it smaller. We'll have to wait until semester 2, KJ, until we see how to make it bigger.
Semester 2 is very hard.
Um,
Very hard.
no, the same as semester 1.
What's the difference?
Different topics.
Yeah, no. What's the difference between math semester 1 and semester 2?
Maths,
Yeah.
big difference.
How big?
Big.
How big?
Very big.
Semester 2, more material, right?
Semester 2, maths,
Math and physics.
maths, much more difficult.
No, I mean, the
Very
It
difficult.
will kill
material.
you.
Maybe it won't kill you. Maybe it'll nearly kill you.
Oh, no.
And physics, well, the good news is physics is the same difficulty.
No, I mean more materials.
Ah, no, the same size.
How about chemistry? Oh, you
I'm,
have physics.
I have no idea. I just know for physics, the good news is it's the same difficulty. You know, it's not really easier or more difficult. I'm sorry to tell you, maths more difficult, much more difficult. Semester 1 is easy compared to semester 2.
Semester to learn about atoms.
In physics, yes. We at the end we talk a little bit about spin up and spin down, but not really. You talk about this in chemistry as well.
I tried to get questions for semester 1, but I couldn't. the bus is
We'll talk about this, don't worry. We'll talk about this. Yeah. Okay.
English. What is too many English?
Too much English. Too much English.
It's too much English. I hate English.
I know you do, but your English is improving. Don't you think so?
Yes, I think so.
No, I
Ah, we think so. We think so.
except me.
Okay, well, your class thinks your English is getting better, don't you? Yeah? Remember at the start, she wouldn't say anything? And now,
So quiet.
blah, 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 always talking.
She was almost silent.
Almost silent, yeah. Now you're more like Carrar, always talking, blah, 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 blah. All right. But don't worry, Carrar, you're not the number one talker. Yeah? I think you know who the number one talker is.
Yeah.
Yeah? Who do you think it is?
Yeah, I know.
Who?
Someone.
Okay. Right. So let me give you. I'll give you an example. I don't have to use this example. I'll just make one up. So let's say here we have 10 volts, and here let's say this is 100 milliohms, and here is 200 milliohms. And my question is, what's the voltage here? So if I use my formula, V out equals, what is it? R2 over R1 plus R2 V in. That is 0.2 over 0.1 plus 0.2 times 10, which is 6.67 volts. Yep. What's what? This here
What's
is,
the question?
the question is, what's the V?
We on?
V out, yeah. This is 200 milli and this is 100 milli. Yeah, well, I'll give it. This isn't a realistic example. The reason this is not realistic is because I didn't actually connect anything to the output. Do you know what I mean? Like here, I'll give you an example. Like, what's the voltage here? This is 220. 220. What voltage does this need, do you think? No.
180?
No, I think only maybe like 12. It's quite small. So you could use something like this to reduce the voltage from 220 down to 12. Okay. In my picture here, I don't have anything connected. There's no iPad here. You know, this potential divider,
Yeah, the charger.
it's like this. This is like the potential divider. But there's nothing connected in my picture. So what I'll do is, I'll do an example now where we connect something like an iPad or something like
Why
this.
always the power line is like 220?
It's easier to go from a big voltage to a small voltage than a small voltage
Okay,
to a
maybe
big voltage.
something in more than 220.
We'll deal with that in semester 2. Yeah. Huh? Yeah, I'll draw it for you. So here's the idea. You have something like a plug. This is 220 volts. And then here you have an R1 and here you have an R2. Let me move this. Like this. Okay. And what you would do is you would connect your iPad here. You got the idea now, Grace?
Yeah.
So this here, what it does is it takes 220 volts and makes it smaller for the iPad.
No.
No? Okay. You know what an iPad is, don't you?
Yeah.
Yeah, okay. Right, so... Oh, that's just the first thing to check. Yes. So yeah... No, it's two. We connect the iPad here. So, for example, if this is positive and this is negative, the current will go along like this. Some current will go up, some will go across. So what I want here is I only want maybe like 22 volts, but this here is 220. So I can pick the R1 and the R2 to make this 22.
So we need is what iPad has.
What's R1 and R2?
Might I need the
Yeah, go on, yeah.
No, I forgot my
Okay. Karar, do you know your question?
might I need more than 2 resistance?
No.
Okay,
No.
so I need like less than 20. I need 10, 12.
Yeah, well, let's calculate it, okay? So let's say, for example, R1 is 100 milliohms. Then my question is, what should R2 be?
Oh, is your question we know the iPad is...
Yeah, in my question here, I know this, I know this, I know this, I want this R2. This is the question. This is my question. Yeah. So if I use my formula, I have 22 equals R2 over 0.100 plus R2 times 220. So when you solve this, you get R2 equals 10 milliohms when you solve it. No, it doesn't. Sorry. I tried to do it in my head. I can't. Yeah, I'm going to need a calculator. Right, so we get this divide this, so I get 1 equals R2 over 0.1 plus R2 times 10. So now I get 0.1 plus R2 equals 10 R2. So then 9 R2 equals 0.1. So now I have my answer. R2 equals 11.1. No. Yeah, 11.1. Is it 11.1? 0.1 divided by 9, KJ? Is that 11.1? Sorry, 0.011. Which is 11, yeah, milliohms. Yeah? No. Oh, Amanda. Wait. I'll get it. Who will be back? Oh, I know him. I don't know his name. Okay, you got this? Yes? Yes? Okay, can I draw again? So what we have is this is 220 volts. What did I say this one was? 100 milli, and the other one? 0. Yeah, well I want to keep it in ohms, okay? Right, and here I have an iPad, which I'll call the resistance. I'll just say, listen please, I'll just say the resistance in an iPad is, I'll make it up, I'll say it's 2 ohms.
What is second
Which?
resistance?
This one? 0.011. It was the answer here, Grace.
It's together.
This continues, yeah.
What do you want?
Yeah, so my question here is, the resistance here is 2 ohms in the iPad. Now, this is very important, so I'll wait until you're ready. Okay.
Stephen, what's the meaning of that?
Of what?
Multiply?
Yeah, Tekken, multiply what though? White space? Come on. You know what I mean, 0.1.
Oh, I thought
You thought it was multiply as well? Oh, guys, you make teachers sad.
I think the point is just
A point, yes, okay.
it's nothing.
Alright, is this okay? Yes?
Big class.
Thank you. Now, in this example, I've continued from the last example, except this time I gave you the resistance of the iPad. What's the resistance in the iPad? 2 ohms. What is the voltage in the iPad? 22. Now this is important. Listen carefully. The voltage is not 22, it's nearly 22. And the reason for that is because the R1 is 0.1, but this is the R2, which is now not 0.011.
It's equal to 2.001.
Let's calculate what the R2 is. The R2 is found by using this formula. You remember this formula? Yeah? So can someone give me the R2? 1 over 2.011, is it? No? Kitchen. And then, there you have it. The answer is 0.109. Now look, please look up. See, this R2 is not very different to the R2 in the last part. So in fact, the answer should nearly be 22. What I want you to do is calculate it, please. V out equals 0.0109 over 0.011 plus 0.0109 multiply 220. What do you get? I think it should be something like this. 21.9, is it? Type this in on the calculator. Tell me what you get. No. It's no. No, it has to be near 22. It can't be 400. What is it? What is it? 100. Oh, sorry, my bad. I wrote the wrong number here. 0.1. Okay, try again. 21.6 volts. So you see, it's nearly 22. Yeah. So just a couple of things to note. Can I go down?
Yep.
Yep. So here we'll call this one OR1, and we'll call this one OR2, and we'll call this one here OR. No, just a summary of the result. And this here is V in, and this one here is V out. Okay, so first thing to note is normally OR1 and OR2 are small, and then OR is big. If, I'll wait actually. Okay, can I go on? Okay. If there's no external resistance, then you have this formula. V out equals OR2 over OR1 plus OR2 V in. If you have external, that's equals 0 now, I'm sorry, equals 0. If you do have external resistor, like an iPad,
So it's the same.
no, this is the thing. I'll explain the small difference here. Okay? So, in the first example, there was no resistor at the top. Okay? So then you have this formula, which is exactly right. In my example I did, what was my V out? It was 22, wasn't it? Now, when I connected my iPad, was the voltage still 22? No, it was 21.68, which is close, yeah? So that's why here, Karar, I changed it to this, approximately. Do you see? Grace, are you listening?
No.
Okay. Please listen. So, in the beginning, there was no iPad. What was my V out? 22. And I can use this formula. Then, when I connect my iPad, what was my V out? 21.6. So that's why here I have this. It's roughly, approximately. If you want to be more accurate, you need to change the OR2. You would need to use, you would need to use this formula. 1 over OR total equals 1 over OR2 over 1 over OR.
In the state of R2, I have to put only R.
Say again?
In the state of R2, I have to put
In
R.
this formula?
Yeah.
Well, you have to add them together.
Yeah, add them together I call them R.
Well, I called it OR total.
Okay.
Yeah, so, yeah? So if you want to be accurate, it would be OR, well, OR total means these two together.
R2 total.
Yeah, okay, well, you don't want to call it OR total. What will we call it then?
Can I call it only R?
No, I already used OR for the top one.
R2 total.
I'll call it R dash. Okay? So R dash over R1 plus R dash Vn. So this would be roughly, and this would be accurately.
In the exam, which one I have to apply, the roughly or
In the exam, they don't like the roughly one. I just did it to show you that it's nearly the same.
Okay.
So they don't want this in the exam. They want you to be accurate for this one. In the exam, you need to use
The red one.
this and this. They don't want you to use this one. Although the answer is nearly the same.
They want the
Accurate, precise, exact. Oh yeah, so usually as well, what happens is, you see here, this is normally a variable resistor, meaning you can change it. You know, you change it so you can change the V out. Yeah. So if you want, like look here, the R1 and the R2, which is bigger? R1 was bigger, R2 was smaller. Yeah. So if you want to make a small voltage, you make the R2 very small. If you want to make not so small, just a little smaller voltage, like 220 to 200, then the R2 should be nearly the same as the R1. So usually for these, the R2 can be changed. You can change it. So in my example here, I would need to change it a little bit because I have 21.6. So I would need to change it a little bit. In fact, you have these at home. Do you ever see those lights that you can turn to make it brighter or darker? Yeah, that's one of these. So what you're changing is the R2 or the R1. So when you bring this all the way to 0, the R2 is 0. And when you put it all the way full, then the R2 is whatever the maximum is. So that's how these work. You know, so in fact, does anybody have these lights at home? The ones you can turn? Yeah? Huh? Like an hotel, yeah.
It's
You know, it's like this. Huh?
laptop, you can use it.
Our laptop probably uses something fancier than just something like this. Yeah. You know, my physics teacher used to tell me when he went to the cinema, you could see one of these on the wall. So it would be a big tube, which is the big resistor, and at the start of the movie, the person would pull it down to change the voltage to make the lights go down. Yeah,
Physics teacher.
my physics teacher. He was an old man.
Yeah.
Okay, so that's potential divider. It's a very special type of circuit that you use to reduce the voltage. Yeah? It's just to finish by saying it's really important for things like your laptop, because your laptop only needs like 3 volts. But something like this would be 220. But the inside of your laptop, like the processor, the CPU, you know what I mean? This only needs like 3 volts. If it gets too much, it breaks. Yeah. So, these are very simple ways to reduce the voltage. Okay? Let me give you the questions for homework. Just one question. Is that okay, Jay? It's only one question. Question 1, A to L. English everywhere.
Yeah. Oh.
I will do something.
Yeah, later today. After I talk to my problem students.
Your problems, yeah?
My problem students. Oh, they're big problems. They're sitting in front of you. Okay, we'll finish.